Hello and welcome. In this video, we will look into graphing a polynomial function from factored form. In example number 4, we have f of x equals negative x plus 2 times x minus 1 times x minus 3 squared. As you can see, the polynomial function is given in factored form. Step number 1 would be to determine the degree of this function. And when the function is given in factored form, to determine the degree, we look into the powers of each factor. So we have the factor of x plus 2 to the power of 1, the factor of x minus 1 to the power of 1. Remember, the power is 1 when we see no exponents. And x minus 3 is raised to the power of 2. So the degree of this polynomial function would be 1 plus 2 equals 4. And to be noted is that this is an even degree polynomial function. Next, we need to consider the leading coefficient or the sign of the leading coefficient. The sign of the leading coefficient is found by looking into the coefficients of x in every factor. Remember, we are starting off here with x times 1, x times 1, x times 1, and we also have a negative 1 as a coefficient at the very beginning of this function, which means that the coefficient of this polynomial function will be negative 1 times 1 times 1 times 1, which equals negative 1. So what we need to note in here or keep in mind is that the coefficient or the leading coefficient is negative. Next, we have to determine the x-intercepts. To determine the x-intercepts, when functions are given in factored form, we are going to make each factor equal to 0 and derive the x-intercepts from there. So we're going to say if x plus 2 equals 0, it means that x is negative 2. If x minus 1 is 0, x is positive 1. And x minus 3 equals 0 means that x equals 3. So I will list all the x-intercepts. So negative 2, positive 1, and then positive 3. Very important to notice in here is the power of the factors from where we derive the x-intercepts. If the power of the factor from where we derive the x-intercept is 1, it means that this x-intercept will be a first-order root or a first-order x-intercept. Similar to this, we're going to say that x equals 1 coming from a factor x minus 1 to the power of 1 means that this is another first-order x-intercept. And lastly, x equals 3 is an x-intercept that will derive from x minus 3 to the power of 2. Because the power is 2, we call this a second-order x-intercept. Now, why do we have to look into the order of the x-intercept? The reason why is because depending on the order of the root or order of the x-intercept, the shape of the graph at the x-intercept will be special or different. So, remember that first order, the graph will cut through the axis. Second order x-intercept means the graph will make a turn at the x-axis. Third order is when the graph will show an inflection point at the x-intercept. So let's get started with sketching the graph. Now, because the degree of this function is even and the leading coefficient is negative, we're going to say that the end behaviors of this graph will resemble the end behaviors of the simplest even degree polynomial function, which is second degree, or the parabola, with a negative leading coefficient. So try to imagine a parabola with negative leading coefficient. That means that the parabola with negative leading coefficient will be a parabola that opens down. The behaviors of any even degree functions will be similar to the behavior of a parabola. And in this case, we have a 4th-degree function, which seems that will extend from this quadrant here, quadrant 3, to quadrant 4. Now, next thing we want to look at is the roots. Now, the roots of this function are at negative 2, 1, and 3. So we're going to do a little bit of scaling here. So x equals 1, 2, 3. So these two are roots. And x equals -2. Okay? Now, it can be helpful to find the y-intercept of the function in order to draw a more accurate sketch of the graph. And to find the y-intercept, we can substitute, or we have to substitute x by 0, always. So that will give y equals, or f of 0 equals, -1 times 0 plus 2. So wherever you see x in the equation of the function, then you replace it by the number 0. So that means we have 0 plus 2, then 0 minus 1 multiplied by 0 minus 3 squared, which equals -1 times 2 times -1 times -3 squared, which is 9. So the y-intercept in this case would be equal to positive 18. So I will pretend that this is positive 18, so that's the scale that I'm setting. That's because it's limited space. And our interest here is in showing that we know how to sketch the function, so we know how to shape up a function and to describe the end behaviors based on the equation. So that's the y-intercept. So I think that I'm now ready to start sketching the graph. I know that the graph should start in quadrant 3, okay? And we discussed this before, right? So even degree again with negative leading coefficient. And to draw the graph of this function, then, I am going to start in this quadrant and walk towards the first x-intercept, which is at -2. Now, I know that this is a first-order x-intercept, which means that the graph must cut through the x-axis. So I will continue without making any special shapes in there, so continue the line by following the pattern. Now, next, what I'm going to do is try to make a turn somewhere and go back to hit the y-intercept. The reason why we want to make a turn is because we want to hit the next x-intercept, which is at 1. So I won't forget to include the y-intercept here, and then I will go down towards 1 slowly, and then before I cross x equals 1, or before I touch the x-axis, I will double check and see what order root I have here. So that's first order, which means that I can go straight, right, and cut the x-axis through. And then I will continue my journey, keeping in mind that my next x-intercept will be 3. So I need to go back to x-axis and intersect at 3. And the order here is 2, which tells me that the shape of the graph at x equals 3, at the next x-intercept, will be a turning point. So I have to make a turn there. So obviously we're going back now, and I'm going to draw the arrows at the end, and this will be a rough sketch of the graph of this particular function. It satisfies all the conditions. I'm going to check at the end. So the end behaviors seem correct. The x-intercepts are all there. That's first order, second order x-intercept. Now, there are a lot of other inaccuracies in here because this is just a rough sketch. It's not a real graph, the actual graph. For example, this point in here may be a lot higher, but this is something that we are going to learn in the upcoming lessons. I hope this made sense. Thank you for learning with me. Bye for now.